Great to see you here again. My name is Luc de Ceuster and I'm founder of the Ceuster Academy. We are offering you a new YouTube video about the conversion between octal and hexadecimal numbers. But before we start, do not forget to click the subscribe button, click the bell button, so that every time we have a new video, YouTube will inform you. In this video, like I said, we're going to talk about the conversion between octal, hexadecimal, and octal. Now we have the same elements we have here. The hexadecimal numbers or the coefficients go from 0 to 9 and then from A to F. When we look at the conversion from octal to hexadecimal and vice versa, we have to do this in two steps. First of all, we have to convert all the elements, the octal number, to binary. So the octal number will be transformed into a binary expression, and that binary expression then will be transformed in a hexadecimal number. Let's have a look at the first number, 725. Octal number, of course. Let's see what this means. So basically what we can say here, this is 7 times 8 to the power 2 plus 2 times 8 to the first power plus 5 times 8 to the 0 power. Basically this means 7, so we have the binary expression of 7, we have the binary expression of 2, and then we have the binary expression of 5, which is 101. So this is the binary number that corresponds with the octal number 725. The next thing to do is to split this binary number in groups of 4 bits. We have the first number here, we have the second number here, here we have 0, so basically I will not write them, but we know that here we still have 3 zeros. We have here 16 to the power 0, the first 16, 16 to the power 1, and here 16 to the square. Now we have to write the coefficients. What are the coefficients that we find here? Now here we have 0, 1, 0, so this is 4 plus 1, which is 5. Here we have 8 plus 4 is 12, plus 1 is 13, and 13 we know that that is equal to A, B, C, D, and the last number is 1, so this is equal to 1. What we can conclude here is that the hexadecimal equivalent of 725 is equal to 1d5. Of course, in hexadecimal notation. Let's do another example. In the second example, we will convert 6527 octal to its hexadecimal equivalent. So we have here 6 times 8 to the power 3 plus 5 times 8 to the square plus 2 times 8 to the power 1 plus 7 times 8 to the power 0. Again, like we did before, we will write the coefficients in their binary form. So 6 is 1, 1, 0, 5 is 1, 0, 1, 2 is 0, 1, 0, and 7 is 1, 1, 1. So that's the binary expression of the octal number 6527. And doing this, it will be easy now to find the hexadecimal equivalent. We take again the 4 groups, the 4 bits, and we find these numbers here. So here we have the first 16, 16 to the power 0. Here we have the second one 16 to the power 1, and here 16 to the power 2. So we will have an hexadecimal number which is composed of 1, 2, 3 numbers. First one here, so we have 7. We have this, so this is still 7. Here we have 8, 4 plus 1. 4 plus 1 is 5. And here we have 8 plus 4 is 12 plus 1 is 13. So this is again D. And now we find that the number, the result is that 6,527 in octal is equal to D57 in hexadecimal. So those were the two examples of conversion from octal to hexadecimal. Let's now have a look at the conversion from hexadecimal to octal. Let's convert the hexadecimal number B1FD3 to an octal number. First of all, I write it as a sum of powers of 16. So we have B times 16 to the power 0, 1, 2, 3, 4 plus 1 times 16 to the power 3 plus F times 16 to the power 2 plus D times 16 to the power 1 plus 3 times 16 to the power 0. We know that B is equal to 11, F is equal to 15, and D is equal to 13. So what are the numbers that we find? So here we find the number 11, 1, 0, 1, 1. Then we have 1, which is 0, 0, 0, 1. 15 is 1, 1, 1, 1. 13, D is 1, 1, 0, 1. And 3, the last one, is 0, 0, 1, 1. What we're going to do now is to split this number in groups of 3. So we have the first group of 3, we have the second group of 3, the third, fourth, fifth, sixth. So we have here 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, 8 to the power 4, 8 to the power 5, and 8 to the power 6. And now we have to write the coefficients. So basically what we will find here is that we have the numbers. The first number here is 0, 1, 0. So this is equal to 2. Here we have the number 4 and 2 is 6. Then we have the number 1. We have 7, 7. We have 4. And finally, we have 3 in base 8. So basically what we did, we converted the hexadecimal number B1FD3 into its octal equivalent, which is 2617743. Index 8, of course, to be sure that we all understand that it is an octal number. Let's do another exercise. Let's now, as the last exercise in this video, convert the hexadecimal number 2AF3 to an octal number. Like we did before, we write this as a sum of powers of 16. So 2 times 16, 0, 1, 2, 3, third power, plus A times 16 to the square, plus F times 16 to the power 1, plus 3 times 16 to the power 0. We know that A is equal to 10 and F is equal to 15. Now we write those coefficients in their binary expression. So 2 is 0, 0, 1, 0. 10 is 1, 0, 1, 0. 15 is 1, 1, 1, 1. And 3 is 0, 0, 1, 1. And the last step is to select or to split the binary number if groups of 3. So we have these groups, this, and this. And we see the last one, the last 0 doesn't count anymore because it's only zeros here. So we have a to the power 0. Here we have a to the power 1, a to the square, a to the third, a to the power 4, and a to the power 5th, but that will be equal to 0. So when we now transform or write down the decimal equivalence of those coefficients, we find that this is equal to 2. Here we have 4 plus 1 is 5. Here we have 3. This is 4 plus 2 is 6. And the last one is 3 in octal notation. So the hexadecimal number 2AF3 is equivalent with the octal number 25363. So that were the exercises related to conversions between octal and hexadecimal to octal. That's the end of this video. But before we leave, I want to remind you to read the text below the video. You find all our interesting courses and coupons that will give you a very nice discount when you would buy the course. And it's the last element of our YouTube video. Do not forget to subscribe, click the bell button, and every time we have a new video, YouTube will inform you. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.